Hey everyone, welcome back. So in this lesson, in this video, we're going to be applying some of the new skills and concepts and terms that you reviewed in the last video lesson. So before we get into this lesson and these examples, I want to quickly refresh your memory on what you have learned. So of course, like, you defined a vector, right? And so you're confident and aware of the fact that a vector involves a number and direction, right? Like, you talked about the difference between vectors and scalars. You also learned about component form. Right, so A, B. And that the component form, the tail is at the origin. You also learned about a little bit about magnitude, and you saw how Pythagorean theorem played into this, right? So the magnitude is the length of the vector, and then the direction is the angle, right? And an angle in standard position, which is what you know, is from the horizontal, right? Going counterclockwise. What you've known. You also talked a little bit about resultant vectors and adding two vectors together, and linear combinations. You looked at how that ties in. Let's see, what else did you learn? Well, I guess I can go back here, and you learned this. So this was a squared plus b squared, right? And the absolute value, right, is kind of like what it is because it's always positive. So this is the magnitude that indicates magnitude. What else should I remind you guys before we keep going? Oh, you learned about unit vectors, right? And the two nice unit vectors where I was 1, 0 and j was 0, 1. Oh, sorry, I forgot the 1. And being able to standardize vectors, right? So being able to standardize them like in terms of I and j. And that also went with this resultant vectors and the linear combinations. You transform to component form. I think I touched on most of it here, right? So there was a lot of new terms, but some old skills were definitely tied into this, bringing in some old things that we have learned. So what we're going to go through now are some examples of how to set up and solve applications involving this stuff. So figuring out what exactly do I need to do? What does this look like? How could I draw a picture to represent this situation? And what exactly is it asking me to find? So you have linked on the page is a example sheet that you guys have. If you want to pull that up, I'm going to be going through some of those examples right now. So let's get started with number 1. So 3 forces with magnitude 100. Oops, I'm in the wrong place. I went backwards. It's okay. So Miss Getz throws the football at a 38-degree angle with horizontal direction. Okay, so 38 degrees with the horizontal is an important thing for me to remember. 38-degree angle with the horizontal with an initial speed of 12 meters per second. Okay, so let's picture what this looks like. So it's 38 degrees with the horizontal. So there's the horizontal. There's where it terminates, and that's 38 degrees. So we also know that the speed that she's throwing it is 12 meters per second. Right, so we're able to set this up. And say 12 cosine 38, 12 sine 38, right? And so you talked a little bit about where that comes from, but of course, you're thinking about it, and it's saying, well, what's the horizontal direction? What's the horizontal speed? And what's the vertical speed that results in this, right? So you're looking at the horizontal and you're looking at the vertical, right? And you're going back to what you know, and that's where I'm getting 12 cosine of 38, right? This is adjacent hypotenuse is really what we're thinking about. And so I can multiply this out and I'm going to get 9.5 meters per second, 7.4 meters per second. So it's the horizontal component and the vertical component. Okay. So what about here? A tank on a mission cruises through enemy territory at a velocity of 27 miles per hour. So there's the velocity. And a bearing, let's grab a new color. Ooh, we haven't said that one, of 161 degrees. Our goal is to find the component form. So bearing, let's talk about that for a moment. What is bearing? So bearing is always going to be from the north, going clockwise. So it's not the angle in standard position, right? It's not what we know as theta. It's from the north going clockwise. So this right here would be 161 degrees. Can you find theta? Absolutely, right? We know different pieces of this. Like if I can figure out what is this part, then I've got theta. Then I've got the angle in standard position, right? This is going to be a negative angle. We know that this part is 90, right? So I can just go ahead and say, well, 161 minus 90 to get this, right? And I'm going to get negative 71 degrees. So with that information, sure, I can write this in component form, right? Just like we did before. 27, right? This is, the velocity is 27 miles per hour. 27 cosine of negative 17, 27 sine of negative 17. So I'm going to get 8.8 miles per hour, negative 25.5 miles per hour. So it gives me the velocity and the direction. What about here? So this is we're adding on a bit. Let's see what happens here. So an airplane is set on a course with a bearing, there's that nice word again, that a bearing of 352 degrees at 290 miles per hour. Okay, so that's what the airplane, that's the course the airplane sets out on. However, a wind is blowing 300 degrees at 46 miles per hour. So this is acting on this, right? So therefore, what is going to be the actual velocity and the actual bearing of the plane, right? When it's impacted by this wind, what happens? So really what I have here is I have two vectors, right? I've got two vectors that I'm thinking about here. And I want to know the resultant vector. So I have this 290 mile per hour airplane at a bearing of 352. So remember the bearings with the north going clockwise. So that's a little bit before I get to 360. So I've got this vector, 290 miles per hour. And I can certainly figure out theta. You can figure out the angle in standard position, right? So that would be 352, 90, and 8. What is that? 98 degrees. And then I also have this wind going at 300, which is like right here, 46 miles per hour. And that would be, so if this is 300, this is what, 150, right? So I want to know I want the component form of both of these vectors. And then I want you to think back to something from the last lesson about what could I do with these two to kind of visually see what's happening, visually see where does the course of the plane end up? Like it's trying to do this, right? It's trying to go this way. Like this is the direction it sets out for, but it's this wind that's acting against it, that's pushing it to the side. So how could I draw that like actual path? Right? And so the plane vector, so before we do that, think about that. The plane vector, I've got 290 cosine of 98, 290 sine of 98, and then the wind vector, I've got 46 cosine of 150, 46 sine of 150, right? So those are these two separately. So this is step one, this is step two. And then I need to find the resultant vector. You might know what to do, but let's take a look at what does this actually look like. Right? So here's what I can do with them. Well, what did I do there? What was something you learned in the last lesson that I'm actually doing here? Remember how you know if two are equivalent? Two vectors are equivalent? Well, one of them was pretty obvious, right? They have the same component. The other one it has the same magnitude and direction. So you can like copy paste, right? I can take this whole thing and I can't actually drag it. I wish I could. But if I could take this and kind of like transplant it right here. Oh goodness, that's not very nice. That's fine. Right? Where this is still 150 degrees with the horizontal. And I'm just moving it. It's the same vector. Right? It's the exact same vector that I started with. But then I'm able to see a little bit more. Well, what is the result of this, of combining these two vectors, right? And so I've got these two, and that purple one, is the resultant vector. So I figured out the component form of the wind and of the airplane. Well, now I need to figure out what do I do with those to get the result. And you might know. You got to add them, right? So I just got on the last slide that we had 290 cosine of 98, 290 sine of 98, and then to that, we're going to go ahead and add 46 cosine of 150, 46 sine of 150, right? And you're adding this and this and this and this. Go ahead and try it in your calculator. You should ideally get negative 80.2, approximately 310.2. Right? Think about the quadrant. That makes sense, right? Negative 80.2, 310.2. So I haven't actually answered this question. What is the actual velocity? Right? I have component form, but how do I take component form and get the magnitude? Right? And so that's what I want to do, the magnitude of the resultant vector. And so this is what we saw last time. Negative 80.2 squared plus 310.2 squared. And I get about 320 miles per hour. 320.4 miles per hour is what I'm going to go. I guess I could say these are miles per hour. Oh no. So now we've got the actual velocity. So now we need to figure out the bearing. Well, how do I figure out the angle, right? I'm going to have to find the angle in standard position first. So I want to do a few things. I want to think about the quadrant, and then how do I find the angle? Oh, inverse, right? So I can go ahead and use this. So the tangent inverse of, I can ignore the negatives, or I could put them in. It's up to you. The tangent inverse of 310.2 over 80.2. And you've done this before. right? And so we can use our calculators and say the tangent inverse of 310.2. I'm going to do it in degrees because that's what it's given to me in. And that's more common. And I get 75.5 degrees about. Right, so that means that this angle is 75.5 degrees. But I want to figure out this, right? The bearing. So I want to know, like, from the north all the way around to here, what's that angle? Oh, well, we know how to figure that out, right? So the resultant bearing, what do I have to do? I just have to add 270 degrees, right? So starting, that's from here to here, plus 75.5. And I'm going to get that the bearing is going to be 345.5 degrees. All right. So two vectors there acting on each other. So let's take a look at this one. This picture that I drawn for you. So two cowboys have wrangled a wild llama. One pulls on the llama at 21 degrees with a force of 20 newtons. The other pulls at 17 degrees with a force of 30 newtons. It's in the diagram. Despite all of their pulling, so they're going in different directions. But despite all of their pulling, the llama holds her ground. What is the magnitude of her resistive force? Okay. So let's take a look at Cowboy 1 and Cowboy 2. So Cowboy 1, we can think about this, is going to be, let's get the component form of this vector, right? So 20 cosine of 21 degrees and 20 sine of 21 degrees. And then this, right? So Cowboy 2, let's be careful with this one, is going to be 30 cosine of negative 17 degrees, 30 sine of negative 17 degrees, right? So I want to remember that it's with the horizontal. This is in standard position, so with the horizontal. And so when I go ahead and do this, I'm going to be combining these two, right? So I'm trying to figure out, like, what is the magnitude of this that she's resisting? So I need to figure out, like, the magnitude, the actual magnitude that they're being pulled, that she's being pulled. So when I go ahead and do 20 cosine of 21 plus 30 cosine of negative 17, I get 47.4, right? So the resultant vector, 47.4. And then 20 sine of 21 plus 30 sine of negative 17 is negative 1.6 approximately. So, of course, we can find the magnitude, right? Pythagorean theorem. So 47.4 squared plus 1.6 squared. I get that the magnitude of her resistive force is about 47 point, or I guess it's probably more than this, right? 47.4 approximately newtons. Right, so I guess it would probably be greater than this for her to be standing her ground. Right, if this is had the magnitude they're pulling her at, or the magnitude of her resistive force would have to be greater than that. Okay. So I'm back to the slide I accidentally wrote on to start. So there is one more example on this worksheet that I would encourage you to take a look at, that we will go over in class and work on in class. So I would encourage you to take a look at it. And other than that, so in this video, you saw some applications of what you learned last time. And I would suggest that you do some of the homework in practice so that you are building some confidence with these skills. Thanks, everyone, and we will see you in our next live session.